Hey guys, welcome back. So in this video, I will be using the general purpose input-output or GPIO to blink an LED. So let's take a quick look at first place for our PCB. We do have two LED already in the circuit. The first LED, the red shining one, is the power LED. So as soon as this circuit, the board is connected to a power source, whatever PC or USB, this LED must be shining. On the other hand, the other LED, the one connected to the port C, pin 13, is not connected for the moment as the port C is not enabled. This one will be in the our example, and we will be blinking this LED by the end of this video. So before we start doing this exercise or programming, the first step should be to understand the electrical circuit behind this LED and how this is made. So let's take a look on it. So as you can see, this is the two LED I've been just showing you, and the first one is just connected between a 3 volt and the ground. So that's why as soon as the 3 volt are achieved, this LED will be shining. However, on the other hand, the LED connected to the PC13 is connected from the other side to a 3 volt, which means that this LED is in active low. So in other words, if PC13 is 0, this LED will be shining, and the opposite, if PC13 is high or 3 volt, this LED will be low or not shining at all. So this is the first step to see. So after understanding the electrical circuit, let's take a look to the datasheet. So as I told in the previous video, the datasheet has a summary of the microcontroller component, and also it includes a very useful and helpful diagram called the block diagram. So let me zoom in. So the block diagram shows the relation between the CPU, the processor, microprocessor, the clock, the peripherals, the GPIO, and also what is the connection between them, which is the buses. So we can see here there is a main two important buses, the APB2 and the APB1, which are connected to all the peripherals. So to enable a GPIO or a peripheral, first thing to do is to go for the register of the bus and enable it. Good. So now that we are clear about it, let's go to the Keil program and start creating our project. As this is the first video of the tutorial, I will start this project and create it from scratch. So I will go to the project, new vision project. I already created the folder actually, so I put Ctrl+C, and I'm going inside the folder, as by creating a project many files would be created, so to avoid any confusion it's better to specify the folder and to keep everything organized. Save, and here I have already a list of microcontroller families listed here because I made some preparation. You can take a look at the tutorial I put in place related to Keil preparation for the whole project. Good, I am putting my STM32F1 03C8. Great, so I do have here my SKU for this microcontroller, and here I do have some component that will help me in my programming. So just for helping and simplicity and avoid any overcomplicated programming, so there will be the KIMSYS or SIMSYS, the core. The core document is all the one related to the CPU setup itself. So this is really coming from the ARM company, and they set up the microprocessor, so that's very helpful and a very good file to add. The other one, the startup, is related to the clock speed. So adding these two one will quite help you to move on with the microcontroller and avoid really extra very complicated steps. Saying so, we can set up our project and we are ready to make the first step. Before adding the file, one of the most important steps is to set up your debugging or the target environment. First step here is to select the right clock speed. Here by default the Keil is choosing 12 MHz. However, if we go back again to the datasheet, so we go back to the first one, we can see that the microcontroller have the internal clock, the high-speed clock, 8 MHz. So that's what we need to input in this parameter 8. And after that there is a step for the debugging environment. So the first one, we will be using first the simulator. This is because if you do not have the SKU or the part, or you're trying to another microcontroller, it'd be always interesting to make further tests. And which is more important here is to set up these two parameters. For this one we have to put the STM32F1 03 and then C8, and here the ARM STM.dll. So if you need more details, I also made some video explaining why I'm putting these parameters. Feel free to take a look on it. And finally we have to select our target, the ST-Link debugger. This is when we will be validating. After validating our simulation, we can upload our code. And for the setting, adding reset and run, so we will not need to push the reset button each time after uploading our code in the microcontroller. So saying so, we are ready now to start programming and putting our first code. Okay, good. So now let's create the main file. So this is a main program from where we will start doing our program. And inside the main file, let's create our main function, main void, as we don't have any input to this function. And only like this, let's add return 0 just for the purpose of understanding. So let's see. Save, run. Okay, one warning because we forgot the last line. And if I save, good. So now we can see we have a program, but nothing inside. Let's take a look. So as we said, we are now in simulation mode, and let's take a look in the debugging mode. So to go there for the debugging, we just click on this button. We have restriction as this is a testing version, and now we are in the simulator debugging mode, and we can have a look to the peripherals. So let's take a look to our general input I/O, the C1, and that's interesting because first of all we do have disabled clock, and this is coming back to our first discussion. So if we would like to use the Gpio C, we need first to enable the clock. So let's go back, close the debugger, and here where we need is we take a look to the reference manual. Well, okay, so to manage the clock or the peripheral, there is a register in the reset clock control. So which one? Here, reset and clock control. And we go for the registers. If you remember, we said that the APB2 is the register that we are targeting, and we need to have APB2 enabled register. Good, let's zoom on it. So we do have 8-bit register. And by looking here, so if we take a look to the definition, if we set 0 means the peripheral is disabled, but if we set 1 is enabled. So we just need to go for the IO PC, so which is input output port C, and we need to set up this bit to 1. Good. So to set up this register and to find it, there is two ways. The first one is to look in the memory of the microcontroller, which can be sometimes quite difficult and challenging, but not very hard. But there is a much easier way. So let me show you this way. You come here and you go for include STM32F1 and this is within the option we selected when we selected our material at the beginning of the project. By including this one, we can access the RCC register and EBB2 enable. Okay, and we need to set only the 5th bit. So to set up this without destroying the other material, better to put or equal, and we have said that we need, I make the input in a hexadecimal input, so 0x10, which is in other word 0b10000, so the 5th the bit number 5 or number 4, so depends on the way of counting. And we don't even need now the return 0. Good. So after we do that, let's save and run. Good. So if we go to the debugging mode now, and we have to run our program and go to peripheral APIO, see, we have enabled clock. That's perfect. So now we do have enabled clock. The next step is to go for the parameters or the registers related to the Gpio. So let's go back to the main program and start working on it. So the next step is to try to configure and to set up the Gpio so we can do our control for the pin. So there is nothing better to take a look again to the reference manual. Okay, and usually whatever the microcontroller, try to take a look for the chapter which you do see general purpose or Gpio. Good. And we will go directly to the registers because it's there where there is most of the answers. Some microcontroller do have a different way of working, but most of the time you will have a configuration or a control register. And our configuration register here, if we read it, there is two particular things. The first thing is Gpio, and you do have here, and you have to add the A to G, so you can control the register itself. And also, for each one, you see that we have a mode 0 here until mode 7, and this is the low one. It controls from the pin 0 to pin 7. And reset value or the initial value is a 444 everywhere. And if we take a look, what does mean a 4? So it's 0010, and so for the mode 00 means it's an input mode, and 10 it's a floating state. So we are not in output mode, and we need to drive it. And the next thing, as this is from pin 0 to 7, as it's a control low, we will need to go for the control high. Yeah, good. And so it's from pin 8 to pin 15. So now that we need to do what we need to do is to put our pin number 13 to output mode, and we can choose whatever the mode we need here, but we still need to update the configuration part for the output mode. And now, as we need just a digital output like a high and low, So we will go for the general purpose output push-pull. So the number we should put here will be a 3, a 1100, which is a 3. Great. So let's go to here, and if you write Gpio C, don't forget this is because we included this library. That's why it's much easier to add this this code. So CR8. So the first step is to remove the number 3, to remove the number 4. So we just and equal, and we put it as hexadecimal, so FF0 F. So this is our first 4 bits, and oh sorry, this one should be 4 Fs. I just split it to not make the mistake. Now, so GPIO C and CRH, perfect, and equal, and we add 0x 003 0000. Good. I think I'm missing. Yeah, I do miss 10. Perfect. Great. Good. So let's save, compile. Okay, no error, no warning. So let's take a look to the debugging mode. Okay, and open our peripheral, Gpio C, and run. So let's go for the PC13, and here we are. So our PC13, our pin 13 for the port C, is an output push-pull mode, which is perfect, and this is what we need. Okay, so now let's load our code into microcontroller. So I think that's better to see what's happening at the same time. So let me make the windows, both windows visible. Good. And to see what would happen. As you remember, if our pin is a 0, this LED should be green. So let's upload. Yeah, and we have it. So now we do have the pin as an output mode and in a low status or 0 status. So let's just change it to control the pin in output mode. So let's go back again to the reference manual, and we have to go for the port output data register, and here it is. So for this port output, it says that for this one, if we can read, so this is yeah, the output register. So if the output here is set for the pin to 1, the register will be high, or if it's 0, the register will be low. So this is, we will use Gpio C and then ODR. Let's put here Gpio C. Perfect. I think ODR will be showing directly, and this one is only 4 bits, so we don't have to worry about it. And if we put like this, so initially, if we go back to the register, so this have a 0000 status. So the pin number 13, so it means good, so it's 0x2000. Let's try it in the debugging mode first to see what would happen. Let's take a look to the peripheral. See, let's run our system, and here you see our pin is getting high. So if I go back and load my program, yeah, as now I have a high pin 13, this LED is getting shut down. Perfect. So now that we know the high and low for the pin, let's create another function to create some delay. So now I will create a random function for the time. So I put void delay. I'll put here void, as we will make no input. So add int e. So for e equal to 0, e less than, let's put 100,000, 10,000, yeah, 100,000, and e plus plus. Good. And do nothing. Yeah, I forgot to do this one. Yeah, and we do have our function ready here. So just we add it. Let's declare it in the top. Okay. And let's create a while. So we can get rid of this. And while one, let's go inside our main loop. Let's run it. And let's put here, so as we created. So the first one, so we put it as a high, and then we put a delay, and then we change it to low, so like this, and the opposite of it, and we add the delay again. Good. Let's save, and before uploading our code to the system, let's take a look how our peripheral during the simulation mode will be behaving. Good. We can see that we have a blinking activity. Perfect. Let's close this, end up the simulation mode, and upload in our system. So this is too fast. So let's add another 0 to our loop. We run again. Still too much fast. So what we can do, so we put here int. We call it rep for repetitive, and here int rep, and here for rep, so we put this one here, rep superior to 0, rep minus minus. Good. Put this here, and the inside loop. Perfect. So let's put here 10 and 10 to see what kind of example we do have. And okay, yeah, we can see, so this is a bit too much. Let's remove 1 0 here. Yeah, we have our blinking LED. So you can see how we could control using this register to make our LED blinking. And this is the same thing to control all the other pins and all the other ports for the microcontroller. I think that's all for this tutorial. It was already too long, but I wanted to go through all the explanation. Thank you a lot, and see you for the next video, where we'll be reviewing how to read the inputs for the microcontroller. Thanks!